Thank you, Prashant, for that powerful keynote and for setting the stage so well for today's theme, AI-powered CTO. Your insights were both practical and visionary, showing us what modern technology leadership truly looks like. Now, we move into a session that dives into one of the most critical components of enterprise success, AI-driven network operations management. In this session, we'll explore how the landscape of network operations is evolving, and what kind of technical backbone is required to power intelligent, responsive, and scalable systems. Leading the session is Bhargav Petla, AI-fication Specialist at Network Science. Bhargava is a seasoned AI professional with deep expertise in generative AI and operations-focused AI solutions, and brings a strong technical perspective on how enterprises can future-proof their network infrastructure. Bhargava and Raj, over to you.
All right. Thank you so much for the wonderful introduction. I have Bhargav with me over here, and yes, today's days we will be totally focusing on CTOs because while the world is changing in the world of AI in AI landscape, CTOs are very much affected because the kind of work they do, be it product management, innovation management, and network operations center, which serves basically this is basically the bedrock of any IT enterprise out there. We will deep dive in this session, and Bhargav has some really, really interesting things for the entire audience. Over to you, Bhargav.
Yeah, thank you, Raj. Thank you, Prashant, and thank you, the AI avatar. I think AI avatars in me Zoom calls became norm nowadays. So quickly, before sharing anything, what I'm going to do in this session, I'll share my presentation. So you will have a deep idea of where will I start, what is our agenda going to be, then follow through it. Yeah.
Absolutely.
So today we are trying to explore the backbone of any enterprise, if you ask me, because monitoring network centers and network operations are one of the critical factors which people think it just stays in the back office. But the decision of taking this session is like how it can impact directly on your revenue as well as your cost, and how it can actually AI change the game of the monitoring. So we are today talking about what if your network's operations center could think for itself. You don't need L1 monitoring engineers. You don't need anyone. Let AI take care of itself. So why I think NOC operations matter more than ever. Nowadays, if you see, AI is growing at an exponential rate. With AI, we all know that there are infra growing, so many servers are coming on, so many monitors are coming on, and each network operations center is very critical to every organization because it is the thing which should detect issues before the humans could. So that's the main purpose of it. And what's happening with these increasing servers are we need to have increase in L1 monitoring engineers. I don't see a exponential growth in terms of the engineers. And we even if we have those engineers to train to them to grow, it will take at least 3-4 months, and there is a huge cost for the human capital nowadays. So to summarize why NOC important or why this session is important, first is like NOC is the backbone of any office or any enterprise. And in NOC, critically, we need to have a 100% target achievement. Like we don't have like today, I only see at 20 issues, 30 issues. We cannot do that. It costs billions of dollars. We see in news like even a single shutdown of Microsoft service, maybe partner service, lost trillions of dollars.
Very true.
So yeah. So Raj, I'm thinking let's start today by understanding the current operational landscape of this NOC system and slowly bring AI to it, like why AI is a backbone of your NOC systems nowadays.
Absolutely, Bhargav. I mean, it's very important to understand how the current operations management across enterprises, not just IT firms, but across various industries, what is the current scenario, so that the AI vision that we are going to see through your demo becomes very clear for CTOs, as in what is the way forward, what is the roadmap that one needs to build. So absolutely, let's deep dive.
Yeah. So then we will talk about real world impact, and if time permits, we will also see the strategic impact and the ROI which at the end of the day, price, cost, ROI is what makes the AI sold itself. Yep. Coming to the current operational landscape, again, I'm saying from the previous experiences we are seeing, these monitoring tools are there. There's so many monitoring tools, SolarWinds or any kind of monitoring tools, give tons of data, 3,000, 4,000 alerts in a single week. And out of all those alerts, we observe that 70% of these alerts are just noise. It doesn't make, it's our false positives. People, maybe some back-end job running at this day, and humans may know this, but they want to again open the alert, see, spend some time. So there is a alert fatigue. And you can see from the another infographic here, 30% mean rate also increased by 2% for 2 hours. What that means is 70% alerts are noise, it's okay. Out of all 100%, 30% of tickets take almost minimum 2 hours to solve. So it's a huge time investment of any engineer and huge volume. And because of these, the operations actually are running in on a bandwidth issue and hiring L1 engineers issue, where you acquire new customers for the same monitoring systems. You completely need hundreds of people, so more, and so much time.
Yes, Bhargav, absolutely. That's very true. And I'm sure you would too agree that still the current scenario, even in 2025, a lot of the monitoring that happens for operation systems, what are the lot of the triages that are already there, that's still being done manually in 2025. I'm sure you're going to touch upon that point. So we are
Yeah,
looking
yeah.
forward to that.
Yeah, definitely. We'll also talk a real case of how we solved and how we bring the ROI and solve the issue of growth at 20%, 30%. How companies come to us. Okay, imagine we have this. Tomorrow we will have 20% more, 30% more, 200x more. To solve that, we need an AI solution. That's where we come in. So one more slide of how traditional NOCs break is some systems have 3 4 monitoring tools, not only one monitoring tool. And what engineers are doing, they are seeing these tools and gathering insights on gathering alerts. Then they'll find out this is a very critical issue, we need to, they will call people and they will try to see whether this issue is very important or not. Then they go to ITSM ticketing systems, etc., and they raise these tickets. So out of those 3,000 tickets we talked in a week, you really think the humans will go thoroughly for all 3,000 tickets? It's very error prone. It's very huge issue right now is happening. Yeah, and cost wise also, it's very expensive. I know I'm talking about cost, but it's very manually driven cost. So all these tools have a cost, all these ticketing system have a costs. Along with the cost, you are also bearing human who is just seeing these systems and trying to integrate those. So overall, if you see knock cost, not only the engineer's cost, it's a shooting up.
Yes, Bhargav. So that's a very interesting point that you bring in. Why cost matters is because simply implementing AI does not mean anything. What matters the most is the ROI. So of course, cost becomes a very critical factor for any enterprise today.
Yeah. So, okay, slowly, I'm trying to inject AI of how it all works. As you can see in this picture, I am going to call AI as a backbone of all the knock systems, knock monitoring systems. It will connect everything like how your human backbone will work without AI engine. It's all again separate systems which you are paying humans to connect those systems and gathering knowledge. So how our AI first knock works, I will show you the live simulation of how it actually works. Before that, I want to discuss what we are bringing to the table is the AI itself not only connects it with monitoring tools and ticketing systems, it thinks this alert is important or not. Okay, there are some child servers. There is in servers there typically is a parent server and child servers. These child servers are causing issues, and we will get each alert for child. But in terms, the parent is the problem. That's why you are getting errors in the child's there. So we also do the mapping of the servers, which AI intelligently understand. Okay, I don't want to raise 3,000 alerts. I want to raise parent, and I will ask my a person who will escalate this ticket to solve that problem instead of this problem. And it's a closed loop automation. You don't need humans in this monitoring. Even though Raj, Prashant, human the loop is so important. Of course, it's so important in solving the issue. Here, just we are monitoring the issue. The first stage of any operation. So the monitoring the issue, it's a closed loop. You don't need of humans. Whatever feedback required, it will go into the ticketing system. We won't touch monitoring, and from there the engineers will pick it up. And engineers can also use our AI, our platform, which we are providing, the AI engine, can ask that why is this issue happening. Now AI will intelligently go through all the data and all the necessary steps it will take. It will give you an answer why this server is behaving like that. Till now, engineers spend 1 hour, 2 hour brainstorming what may have and what finding the root cause of the issue. So that is one of the USP also we are bringing here up here.
That sounds so interestingly, Bhargav, that this is one point that one area that I can think of. The whatever you've spoken till now is that we are moving more from a reactive model to being more proactive, right?
Yeah.
So I think this is the need of the hour for modern enterprises, and I'm sure the audience must be waiting to see the demo that you have
Yeah.
created for
So
us. Yeah,
yeah, I'll just show a simulation because till now we are seeing the slides and it's very hard to explain how
absolutely.
it's being a backbone. So we try to create a simulation for you to understand how it actually works. So these are all mock numbers, mock systems. So it's not actual thing. What if your AI knock could think for itself? So I'll just explain the architecture first, how this system is, then we'll go to the live scenario. So there are monitoring tools. We have multiple monitoring tools, supports any monitoring tool can be connected with our platform. And these monitoring tools will connect to a data ingestion layer where we collect all these alerts and we form a queue system based on the priority. This also makes sense completely how it's happening right now. Here where the magic comes. The alert will be classified P1, P2, P3, P4 based on the SLUs you have. So every NOC system will have a standard operating procedure. We will classify those based on the alert. By looking at the alert only, AI will understand, okay, this is the priority one, this is priority two. And the USP here is correlation, like how I talked about the child and parent. It will try to correlate 20, 30 child alerts and consolidate into one parent alert. So you won't even see those many alerts coming into your AI engine. You will see, oh, out of 3000, maybe only it shows as 30, 40, 50. Then we also enrich. What I meant by enrichment is, while you're trying to create this a priority one alert and you want to create this as a ticket, right now people are going and putting the ticket ID, ticket number, and some details. This AI enrichment engine, which itself write using generative AI what exactly the ticket is, what exactly you need to do, and create the ticket in your ITSM tool, ticketing system tools. Before that, we have a rule engine. Why rule engine? It is the ultimate decision taker based on the inputs you have, whether the threshold reach 80% of your memory uses, you have to raise a ticket. Those kind of rules you can prefed, or AI can intelligently take a decision. And the ML models, it's where the thing starts to learn itself. ML models help it to perform better going forward. So first month it may have 80% accuracy, second month it will reach 85%, third month it's 90%. But our starting of this solution will be minimum 90% because we know how critical ticketing systems and monitoring systems are. And the output, of course, the idea is some integration, and we can also integrate. So few of the monitoring engineers will want to integrate their emails because that's how they are getting the notifications right now. And you don't need to see all these 4 systems, 5 systems dashboards anymore. You only see a single unified dashboard of how I will also show a dashboard how it looks like in this simulation itself. A unified dashboard of how it actually looks of all the tickets, all the issues, what is the improvement and all. Okay, now I'll start simulation. So you can see AI process engine has few layers we talked about. You can see the time how each decision will take place. Alert ingestion takes place in 0.2 second, AI classification in 0.8 seconds, correlation 1.2 second, decision engine. So if you see, it's almost less than 3 seconds. Whenever this alert comes, for suppose here is a alert service unavailable API endpoint returning 503 errors, the impact is very high. So the AI will understand, okay, this is very important, why high impact alert. So multiple systems can fail if this thing is happening. So it raised a ticket. You can see this is the ticket number. Whereas uh, whereas if you see the same thing that came before, the same error, but the AI took its time. Okay, it came 20 times. That means it's a critical issue. So even if the ticket monitoring system, SolarWinds or anything throws the same error multiple times, it will wait and take the decision after, like how human engineers take. We will see this alert, observe for 15 minutes, then we raise a ticket. And some tickets are very false positive. For suppose database connection time, or it may be some error that's happening because of some back job running in the process. So if you can see, we have passed in the simulation around 30 alerts. Out of these 23 false positive, 77% of the things are just not even, we don't have to look at it. Out of all these, only 7 are the actual tickets. For the fun fact, we are showing how much human time saved as compared to the manual automation.
That's a very interesting thing, Bhargav, that you've showed, because even today in the traditional IT services management world, a lot of these incidents are never classified as, P1 level problems till the time it actually affects their actual working of the systems
Yeah,
or
yeah,
multiple enterprise systems that are connected. So that this definitely becomes a very good representation for any network administrator out there to be proactive and check the issues before they actually become very critical for the organization.
yeah. So this is the live ticketing dashboard. So you can see how the ticket is estimated or assigned to your. So we have also an application which will be integrated in the ticketing systems, which will auto assign your people based on the history of similar kinds of ticket solving. That is the active tickets. Ticket analysis is the same thing which we saw. And this is where the AI outperforms the most of the issues which we will be causing in the future. If you can see predictive analysis, this AI is going through all server data and predicting this may happen even before the alert comes. It's saying back job failure pattern detected, schedule maintenance window. It's asking for us to schedule a maintenance window because it's detecting a pattern. So these kind of pattern detections, I think no human can detect with this much confidence level. So you can see the confidence level, anything above 85% is very extremely important. So these are the confidence level that will be indicating how AI can be helpful in this whole NOC monitoring, network operation center monitoring. The same thing, like SSL certificate is expiring 7 days, renewal process initiated. And resolution recommendation, what we can do better to close this current ticket at the moment. So it's suggesting what you should do, as well as the performance optimization to perform better, how we can tune it, how we can solve the issues.
Yes, Bhargav. So that again a very interesting point. So I see a
Yeah,
lot of comments in the comment section from various attendees that what are some of the metrics that can be achieved through this particular solution, or I mean, what are the business metrics a CTO or a CIO can track when implementing such kind of a solution? If you could,
yeah,
just shed some light on that, that would be
yeah,
great.
yeah, yeah, yeah. See, you're talking about metrics, it's coincidence. So the metrics here we can see, of course, the ROI is the thing we are starting talking from the start. The main issue is the cost here, how much cost we can reduce and how much faster we can grow our business. Suppose you have a client, six clients currently, you are managing their NOC systems, as well as you are doing 20 people, L1 engineers for them. How you're getting business, but to install to establish a NOC customer, it takes months because you need to get people, you need to train them on these systems, etc. So the main performance metrics, if you ask me, is how better our business going to be, how good, how fast we can get our new businesses, how early we can expand, as well as how much human hours we saved. Of course, it's all interlinked, and the ROI. So here are the few performance metrics, but it's for the whole system currently we are running. So out of these 65 are auto resolved themselves. That means the error came, the monitoring tool gave you the error, but after that error is closed, the monitoring also gave this error is closed, it resolved by itself. So 65% are auto resolved, and 77%, 77 tickets, sorry, it's not percent, 77 tickets, 77 alerts are false positive, which don't need to be looked at. Only 42 out of all the things we have done till now are applicable to look at it. So you can see it's almost less than 25% of whole tickets. So that dramatic change is very high. And ticket distribution, it's the same ticket distribution. Okay, now we looked at the simulation. Maybe we can deep dive onto the metrics and how the implementation and strategy will takes place of this kind of system. You're thinking this AI system may take months to implement, maybe integration. So we'll talk about how we implement these kind of systems and what is the USP we're bringing in the part of implementation as well as security layer too.
Absolutely.
Yeah. So this is a live simulation and live case study we have done. These are the standard metrics which we think if you guys implement our AI engine, this will be the standard metrics you will be able to achieve. So of course, mean time to resolution have a drastic change from you see 30% of in the earlier slides, right? 30% of the tickets takes more than 2 hours. So that's a huge number. We are reducing it to 40%, minus 40%, and SOPs following around increased by 30%. There's significant reduction in noise, as well as each ticket actually takes less than 3 seconds, but for the safe side, we put less than 5 seconds. Some tickets may hallucinate. And there's no headcount required. I said no human in the loop for monitoring. You will have humans for addressing those tickets, but there's no headcount required after this system. I think we have already devolved in this architecture. Maybe I'll just skim through it. So uh, these are Slack, Microsoft Teams, anything we can integrate anything. It's an open architecture. We work on REST APIs. So anything that is capable of REST API, we can integrate into our platform.
Yes, Bhargav. So on that note, actually, I
Yeah.
believe for a CTO, the time to market for a service becomes very critical. So
Yeah.
for to implement such kind of a system, what do you think is the average implementation end-to-end time that it would be required to implement at scale or a POC? If you could shed some light on that, again,
Yeah.
that would address a lot of queries that our audience is having right now.
Yes. Good thing. So implementation, end-to-end implementation, it will take only 7 weeks. It's not, it won't go more than a day, more than an hour than 7 weeks. We'll do the discovery planning phase with you. After that, we'll do the environment setup. In the previous slide, I have how we'll set up, what are our offerings, but mostly it will be a environment setup will be done, and everything. We'll fine tune our AI model according to your systems, and we will go live. After that going live, you see the machine learning models are there, which will try to optimize and improve itself. So there's less interference needed from our side once we have this implementation, all the from the client side itself. The whole system is automated, and the AI will itself identify the issues and learn from itself. So just a few things just before we close. I think we can skip this. Yeah. So this is just an example of how you guys need to calculate ROI. Whenever I am talking about ROI in this whole presentation, how these things work in operations kind of interview. Sorry, network operations center monitoring. So this is the actual thing we'll be using. Number of FTRs saved into hourly cost minus platform fees, net ROI. These are just mock numbers. Suppose you are receiving a 15,000 alerts, which are very less number. Out of these, as I earlier, based on this observation, 70% are false positive. So 10,500 tickets, you don't even look at it. So only remaining tickets are 4,500. At an average, some may take more than 2 hours, but an average it takes 15 minutes to solve each alert or to raise a ticket to. How much time we are saving is around 15,000 tickets minus 4,500, that is remaining false positive tickets into 15 minutes. These many hours you are saving. For suppose this is an average FTE cost. If you take your cost is the cost you are saving is around I think 39,375 US dollars. And imagine a platform fee or a fee for AI charges is around $2 per alert. So it's depend on the volume and your system, but it's just a number that correlates with your volume. So your total cost will be 15,000 because every alert has to pass through this monthly platform alert. So it's 30,000.
Absolutely.
39,000 minus 30,000, that is 9,375. So you're saving per month $10,000 just with the low amount of alerts. So how important AI in doing all these systems faster, but in terms of cost and ROI also, it's as much important as valuable as it is.
And Bhargav, you rightly said, this pretty much sums up the ROI calculation for any such implementation that we are seeing. So in the
Yeah,
interest of time, Bhargav, we are going to take some questions out of the multiple questions that I can see.
sure.
The first one being, how do you keep implementation risk quite low and the business disruption minimal? Why? Because when you are implementing such a system, of course, you'll have to tweak a lot of your existing services, a lot of your existing systems. So what is your take on this?
So how we implement these kind of systems is we'll do parallel implementation where your day-to-day activities remain same for at least 2 weeks and 3 weeks. Backend we'll integrate all these systems. So the alerts you are receiving seen by humans in the first few 1 week, 2 week, as well as our AI system we also receive. We won't connect it to ticketing system. We'll slowly have a project management plan to transform these backend systems or backend people to get addictive or get used to the AI system. So because they don't need to do anything, and of course they can be used for the ticket more effectively. Their time can be used in solving these use cases rather than just looking. So if you ask me, there's minimal implementation risk for these kind of systems because there's no connection with the existing process. It's just doing everything in the back end, duplicating the process into twice.
Absolutely. And Bhargav, like you already shown the magic. So another interesting question that I can see is, so for enterprises who want to explore the initial use cases, what should be the first step that they should take in order to be ready to implement such a solution?
Okay, that's very interesting question. So first of all, if you want, as an enterprise, you want to start with AI journey, this is the best time to do. And you can start with very minimal AI use cases. Having generative layer is very important. That's where I think the previous leaders and sessions from the last 3 days are talking about an AI OS, how AI is not a use case way, it's a metric backward thinking where you will see it as a OS for your whole organization and keep picking up small things which will in terms give you a bigger picture. So for these kind of applications, for NOC kind of applications, I think it's the best proven ROI and proven issue in the industry. I think this is one of the starting point which you can start with.
Absolutely, absolutely, Bhargav. Thank you so much for the wonderful session. I'm sure we would have loved to entertain multiple questions, but in the interest of time, we have to stop here. But it was wonderful to see what can happen in the age of AI, especially from a network operations standpoint, which once again, like we have iterated this multiple times, but it is the most critical aspect of any modern enterprise. And it's always good to be proactive rather than being reactive in today's time. So thank you so much, Bhargav.
Yeah.
And
Thank you yourself. You have been a wonderful host, and the questions are very right to the point. I hope this session helps anyone, and feel free to anyone can contact me via LinkedIn to understand more on this kind of implementation.
yes,
Yes,
absolutely.
thank you.
Thank you so much, everyone. See you around.
Thank